Hi, everybody, and welcome. Episode 2 of Azure Cosmos DB Live TV. My name is Mark Brown, and today I'm joined by Tim Sander, Program Manager on the Cosmos DB team. How you doing, Tim?
Hey, Mark. Yeah, great to be here. I'm super excited today to talk about query and indexing in Cosmos DB.
Well, that's awesome. Great. Well, won't keep anybody waiting. Why don't we get cracking here? So, yeah.
Cool. So today we'll talk about some high-level best practices about how to query data and index data in Cosmos DB. So we'll break it into two sections. First one is going to be about indexing data in Cosmos DB. So we'll talk about including and excluding paths, which sometimes we call this range indexes. Then we'll talk about how you can use composite indexes to optimize lots of complex queries in Cosmos DB. And then we'll kind of close out indexing by talking about how you can go in, apply those indexing changes, and track the progress of your index transformation updates. Then we'll switch over to queries, talk about the difference between point reads and queries, which is a super commonly misunderstood concept in Cosmos DB. And then we'll close out the whole thing by talking about the difference between in-partition and cross-partition queries, and really talk about a lot of the really important things to understand when running cross-partition queries in Cosmos DB.
Yeah, that sounds cool.
And please post questions in the chat, and Mark, feel free to ask your own. I'm sure you know a lot of the questions that customers typically have when they're talking about and thinking about indexing in Cosmos DB.
Sure, I have questions all the time. As you know, I ping you constantly on Teams, asking you how to write a query or what's wrong with my query or something like that. So I think I might be representative of many of our customers when it comes to querying and indexing.
Yeah, without it, I mean, the good news is in Cosmos DB, like indexing is pretty easy to learn compared to a lot of other databases out there. So if you're used to using, let's say, SQL Server or something like that, another database, like you can learn Cosmos DB indexing in like a fraction of the time. But it is still something new, and it's a very important best practice at Cosmos DB. So it's great that we're talking about it here today. So the important thing to understand in Cosmos DB is there's three kinds of indexes. And when you start out with a new collection in Cosmos DB, by default, we go and create a range index. In other words, an included path for every single property in your collection. So right off the bat, when you create a new collection, we index every property. This is going to be good for most of the queries that you need to run. So whether you're doing an equality filter, range filter, order by, like this will be enough for the bare bones types of queries that you run, and maybe even ones a little more complex than that. Now, it's good to keep in mind that indexing everything, while it's great for optimizing for read performance, it doesn't necessarily optimize for write performance. So there's some things to keep in mind with that we'll talk about next. Now, in addition to the included paths, the range indexes that you start out with at the time your collection is created, there's also spatial and composite indexes as well. For spatial indexes, as like the name suggests, you'd add them on if you're using a geospatial system function in Cosmos DB. And composite indexes are really great if you have really complex filter expressions, aggregates, or of course, the most impactful with order by queries. So we'll go through these three types of indexes today. First thing, start with the basics, is how do you even get to your indexing policy in Cosmos DB? Now, regardless of what API you're using, we recommend updating your indexing policy in the portal. You can update it through the SDK. You can go and make these changes programmatic through CLI as well. But it's really nice when you edit through the portal, especially on your development collections, to just have a visual representation of your indexing policy. So that'll be within the Data Explorer. The scale and settings, we have a dedicated section in both SQL and Mongo API to the indexing policy where you can go and edit what indexes you have.
I had a question. So I noticed we have e-tag included or in the excluded paths there. What about the other system properties? Are those, should we exclude those, or are those excluded already, or what is up with those?
Yeah, that's a really great question. So by default, this is the default indexing policy that you'll get when you create a new collection. And this here, this /* means by default, we included every property. And this exclude e-tag means we're excluding the e-tag property. The e-tag property isn't very useful for querying, so we'll just exclude it automatically for you because there's really no practical use case for it to be indexed. Now there's some system properties like you mentioned, like ID, the timestamp, then even things like partition key, right? Or you could call it system property. Right now, your ID and timestamp are implicitly indexed. So if you're watching this video right now, the answer is even if you haven't explicitly indexed the ID and timestamp, if you're watching this live, those will automatically be indexed for you. We found that a lot of people assume that to be true for the partition key. They assume that partition key is treated the same way as ID and timestamp because it's a system property. So as of right now, at this moment in 2021, partition key is not implicitly indexed, but in the near future, this is actually something we want to implicitly index as well with ID and timestamp. So these properties are used so much in queries that we just go in and index them implicitly for you.
So today, index your partition key. It's not handled for you, but in the future, we're going to take care of that one too.
That's right. Yeah, right now, you do want to make sure it's indexed. That's right.
Okay.
In the future, we'll try to make that more automatic for you.
Okay.
So here I got a sample indexing policy, and it's the same one that was on the earlier slide. I've included every possible index. So /*, right? I've included every possible property in the indexing policy, and I've excluded nothing, right? I've just excluded the e-tag property. We'll say that we have this document here, and it's data about different employees at different companies. So in this case, we have a sample document. The name is Mark Brown. I don't really know this guy. You know, Mark Brown works at Microsoft, lives on 123 Cosmos Road, and his job is a product manager.
Wow.
ID, of course, is just a random viewer.
It's my exact address.
You get a lot of fan mail, I guess, maybe after
Tons of it.
after today. But we basically have a collection. We've uploaded millions of documents that look just like this one, and we've opted to use the default indexing policy. So if you look at what properties are actually indexed based on this policy, we've got ID, right? Because we just talked about how ID is implicitly indexed. Name, address, company, and job, because they'd be covered by this /* index everything policy that you start out with. So obviously, if you had just started out with development, like this would be pretty useful, right? Like you could run queries on all these properties and it would be pretty good. But I'll ask you a question. What would happen if you tried to ingest, let's say, lots and lots of data to Cosmos DB with this indexing policy? If you had a really write-heavy workload?
Yeah, well, it'll all get indexed as I'm ingesting the data and consume a ton of RUs, I'm guessing.
Yeah, exactly. I mean, and if you were going to go query that, like by all means, index every property. That's what it's for. But if you have a really write-heavy workload, it really pays to go to your indexing policy and go and customize it specifically for what you need. So in SQL API, we start out with index everything, but you can go and selectively include paths. So let's say you only ran queries on name and address. You can go and selectively include these paths and then have a blanket exclude everything else, right? By this /* and excludedPaths. Now, if you look at the document here and look at how this indexing policy would be applied to that document, we've indexed ID, name, and address, but we have not indexed company and job because they just were not enumerated as included paths. So if you run a query that filters on name or address, you're in good shape. But if you run one on company or job, you wouldn't have the corresponding index to optimize it. Now, time for another question for you, Mark. If I were to add another property, if I were to add age, right? If I were to add your age as a property in this document, and we won't actually put in that property, but just hypothetically speaking, would that be indexed or not?
That would not be indexed because you're doing basically an explicit index policy.
Yeah, so we'll index these properties. We won't index these, and if I add in a new one, it would not be indexed automatically. So we'd actually have to go and remember, if you added on a new property, if you added on age, if you added on, I don't know, other additional properties, you have to remember, oh, like by default, properties are automatically excluded. So in addition to enabling customers to customize indexing policy by selectively including paths, you could also go and reverse it. You could blanketly include everything except for the paths that you selectively exclude. So like this earlier policy and this one are equivalent for how they treat name, address, company, job, but for any properties that aren't basically explicitly enumerated, the default here would be to go and include them in their indexing policy. So there's no performance advantages to each one. You should do whichever one is easiest for you as you're using Cosmos DB. My personal opinion is this is this one here where you're selectively excluding as opposed to selectively including is a whole lot easier, right? As you're working with data that maybe can have different properties, right? As you're ingesting new data, because Cosmos DB is really great for that schemaless type of design.
Well, wouldn't also, if your schema changed,
Exactly.
keep you from having to rebuild your index because you had to add another path?
That's exactly it, right? I mean, you're constantly in Cosmos DB. It comes up a lot with IoT data. Like, you're constantly introducing new properties to your data. And this is why customers love Cosmos DB, because it's really easy to just slip in a new property into your document, just like we did with age. Super common for these types of scenarios to come up. And I mean, using this type of indexing policy where you've opted to include everything, but selectively exclude some paths, really make that a whole lot easier for developers to work with.
Yeah, I see that in, you're right, and especially in IoT data. Also, IoT data where they've got just a bunch of garbage kind of in a single property that they're passing from whatever device, right? Like, I don't know, could be some base 64 encoded something or other, or something that's you'd never use in a query, basically, in a where clause.
Right. Yeah. Absolutely. So, I mean, we give you both possibilities. You can include everything or exclude everything, and you can pick either one. Now, we touched on this a little bit earlier, but if you have a write-heavy workload, you really want to optimize your indexing policy, right? You don't want to blanketly stick with the blanket index everything, right, index policy. Now, in addition to that, if you have some types of queries like order by queries, aggregates, maybe queries with complex filter expressions, composite indexes can be a really good way to optimize these. So we'll start off with the first query. We're filtering on name, and we're sorting by age. So we're finding all the people named Mark and sorting them in descending order by age. Now, if you run this query with this indexing policy right here, it will run. And to be honest, if you have a few gigs of data, even a few tens of gigs of data, it's totally possible that it'll run just fine. But as you scale up, you may notice that this query will not scale particularly well. In particular, if there's a lot of possible values for Mark, it's possible that this query's RU chart could quickly go into the hundreds or thousands of RUs as you ingest more data. So the recommendation here is to optimize queries with order by and queries with filters. So queries with this equality filter, right, and an order by property with a composite index. So in this case, what we do is we create a composite index. And we do this down here. We create it on name, comma age. So if you had a filter on name and then you order by age, we'll go and exclusively use the composite index for that. In the past, without a composite index, what we need to do is apply the where clause and the order by clause separately, and these would use the index independently from each other. But now, since we have a composite index, we can just go ahead and use that composite index for the entire query execution.
So you want to define, let me see if I get this right. So I want to create basically a new composite index with multiple paths for each kind of where clause that I'm going to use. Is that kind of how they work? I mean, can I just add a bunch of different properties inside the same composite, inside this array of paths? Or do I need to create a separate one for each different type?
So I definitely review our documentation on composite indexes to learn more about this, but it's a really great point to touch on. It's very possible that your collection could have many composite index created. Your Cosmos container could potentially have dozens or more of composite indexes if you have a really query-heavy workload. So if you had, let's say, order by queries that filtered on different properties and sorted by age, very possible that you'd have composite indexes to optimize each of those, and that those would be slightly different. It's also possible that you might have a name equality filter in your query like this, but you might also have a job equality filter. So if you imagine this query here, if we add on, instead of just c.name equals Mark, we'd add on and c.job is equal to developer, right? If we had an additional property in the where clause, we could actually go and add that to our composite index as well. And you can have up to 8 properties defined in each composite index. So That tends to be a pretty big limit. So if you're a customer that wants to use composite indexes, usually you can create a composite index that can be used in your query.
Hey,
now,
so we got a question from one of our viewers here.
okay.
So does the order matter for the groupings of included paths, excluded paths, and composite indexes?
Yeah. So for included paths and excluded paths, the order does not matter. So I could define job before a company before a job, doesn't matter. For composite indexes, the order in which you define the properties in each individual composite index matters a whole lot. Like if I flip this and did age first and then name, that would not be able to be used for this query here. However, when I go and add the composite indexes to my indexing policy, I can go and add them in whatever order that I want.
Okay.
So next question, or next example, it'll be a question for you. As I have an aggregate query here where I'm taking the average age of employees at Microsoft. Now, if I run this query and I find the RU charge is okay, but it's not quite as good as I want it to be, what should I be thinking about in this case if I have an aggregate query with a filter?
Wait, ask the question again?
Oh, so like what type of index should I be thinking about here if I have an aggregate query and a filter?
I don't know. I mean, just a regular index?
So a regular index would work. It would certainly work for this query. However, a composite index could offer a pretty significant performance boost for this query. And this is actually a super new update that we released a few weeks ago, back in, I think it was around February of 2021. In this case, the query would run just fine with included paths. You're absolutely right. But if you wanted to take performance even better, it's very possible that an index on company and age, a composite index on company and age, would improve this query's performance quite a bit.
So it's basically, I see. So you're going to run the aggregate over the composite index on the age. I see. Huh. Now, cool. I got another question from one of our viewers here. Is the composite index created for each partition?
Great question. So when you create a composite index, you specify it at the indexing policy level. And your indexing policy is tied to your entire Cosmos container. So if you have one partition, 100 partitions, it'll automatically get applied to each partition based on what you update here.
Right. So indexes live on the partitions, right?
That's
right.
Yeah.
The partition's going to route the query to the right physical partition where the data sits, and then the index lives within each physical partition.
That's right. And this is actually what we're going to dive into towards the end of this presentation. So if, I don't want to make this answer to that question kind of seem kind of like a half-baked answer, because we're going to spend a whole lot of time talking about this later. But at a high level, you want to think of the indexes in each physical partition as basically separate and independent from one another. So think of the indexing policy that you set to be for the entire container, and those instructions are applied to any data that's ingested across your different partitions. And the index in each partition is separate from one another. So if you execute a cross-partition query, the execution of that query and how it uses the index is independent on each partition where it's executed.
I got another question for you. Awesome. So do composite indexes work with spatial data?
Awesome. The answer to that right now is no. It's something that we could definitely think about adding in the future, but as of now, composite indexes are just for your regular data in Cosmos DB, so it wouldn't apply to spatial data yet.
Yeah, that'd be cool.
Yeah. So in this case, we have the composite index to optimize the aggregate query, right? We're optimizing a case where we're taking the average age of the employees at Microsoft. Now, composite indexes tend to have more of an impact when they're used on high cardinality properties. So for the order by example, we were order by age. In this case, we're taking the average age of employees at Microsoft and pretend age is like an integer, right? So you can be 21, 22, 23, right? Integer values. So a question for you, would you consider age to have a high cardinality?
Not really.
Yeah, it's
Most
not.
people are between 0 and 100, I guess, right? So with most people being, in the mid-range of that. So at least people that work at Microsoft.
People that work at they maybe range from like 20 to 60, right? There's very few that are outside that range.
Yeah.
At most 0 to 100, right? So it's not a high cardinality property. Nonetheless, it's certainly possible a composite index would help here, but where composite indexes will really have a huge impact is with super high cardinality properties. Can you think of some examples of really high cardinality properties? Anything you could think of that comes to mind?
I mean, address would have high cardinality because it's pretty, you know, although I do know people that are roommates that work at that work at Microsoft. So
address is a good one. I mean, there's so many different possible addresses, right? There are many different possible values. I'd say far and away, the most common high cardinality property in Cosmos DB is timestamp. Like this is used so frequently in IoT workloads. This is used really frequently in workloads where maybe you're looking at the time data was written or updated, right? And you're sorting by timestamp. Like if you can imagine like Teams, right? Teams uses Cosmos DB. If Teams is displaying your messages, right? I guarantee you they have some order by timestamp query somewhere in there. So you're basically sorting by a really high cardinality property. And here, if we were to take the average timestamp, we'd be taking the average of a super, super high cardinality property. Now, this is where composite indexes have a huge, huge impact. Now, the next case, we're filtering a name, and I just used ID here. ID is just a random GUID, so this query might not actually make much business sense, but we're just finding all the possible values of ID that are greater than this string here. Now, ID, since it's unique per partition key, is obviously a super high cardinality property, right? So in this query here, a composite index is going to have a huge impact. If we create a composite index on name, comma ID, it's going to improve the query quite a bit. Now, if you had a, let's say we were using age again, and we had name is equal to Mark, and age is greater than 30, for example, right? In that case, the composite index might still have an impact, but because the cardinality of age isn't nearly as big as ID, it's not going to have quite as big of an impact as a query like this, where we're filtering a name and filtering an ID, and using the composite index for really high cardinality properties with range filters is really going to help quite a bit.
Yeah, that's cool. Do you have any other indexing policy examples?
So that wraps up that section. The next thing actually I want to talk about is how you go and apply those indexing changes, right? So we just talked about how you could optimize your indexing policy for write-heavy workloads, and also for cases where you need to use composite indexes, right, to improve query performance.
Got another question for you.
Yeah.
Can we create a composite index on an array element?
That's a great question. This is something that we're thinking about adding in the very near future. I'd imagine the use case that you'd have in mind for this would be optimizing a system function like array contains. So right now, it's tough to use composite indexes with arrays and basically have a wildcard index to index the entire array. If you wanted to and you knew specifically what position the data was within an array, I think you should be able to add a composite index for that. And that typically isn't super useful. What customers usually are asking for in terms of arrays is the ability to apply an array wildcard index to just index everything in the array so that they can optimize array contains with a wildcard index. And this is something that we're building actually right now and should be available in the next few months.
Yeah, cool.
So we just talked about the types of indexing policies that you can create, right? And we showed some different examples. The next obvious question is like, I mean, how do we go and apply these, right? Like, what do we do to go and apply these indexing policies to our collections, and how do we track the index progress? So we'll come into scale and settings. I've got a collection here actually that I've created that has the very same data that we were talking about in the previous examples, where we have ID, name, address, company, and these are just all fictional companies that are randomly generated, and a job. We partition this container based on the job, right? So different possible jobs would be different possible partition key values. Now, if we go to the indexing policy, right now I have a wildcard index in includedPaths. I've excluded eTag, and I've also excluded the company. Now, let's say I decide that I want to exclude another path. It seems my browser was inactive for a while, so I'm going to go ahead and just refresh it. Just give me 1 sec. Bring this over to another window. Get that back set up for you. All right, awesome. Bring this back. So I'll go back to this collection and go back to my indexing policy. And hopefully now I should be able to edit it. Cool. So I'll basically go and just exclude another path. So before I was excluding etag and company, and I've included everything explicitly. Just an example, let's say I had added on age and I want to exclude that. I'll go and exclude that specifically. Now, it's very important when you go and edit your indexing policy in the portal that you pay attention to this banner here that says you haven't saved your changes. Click confirm to save. And when you go in and save your changes, we recommend grouping as many indexing policy changes together into one big indexing policy update. So if you were adding on many new properties to your indexing policy, we actually recommend that you add them on all at once rather than one by one. So here I've just done one change. I apply it. And the good news is that when you make indexing policy changes, it doesn't impact your production workload. So if you had a Cosmos DB workload running and really depending on this account being available, be totally okay. It's safe to make these changes while in production. However, the index won't be available for a while, right? Because we need to go and use your leftover RUs, your RUs that you have available to go and build that new index. So the easy way to track basically how long that's taking is through this banner here. If you see this banner, it'll tell you that your indexing policy transformation is in progress, right? And if you click refresh, you'll basically refresh that check. And you can use that to see if you're close to done, if you're done, and if it's done, like you can go and test out the new indexes that you have. Go back to here. So we'll come back to that.
I get a question. Is there a programmatic way to see whether or not that's still rebuilding or not, like through the data plane SDK or .NET SDK or any SDK?
Absolutely. It's actually in I think almost every SDK if you use the latest version. It's in our documentation for how you do this. So if you just go to that indexing page, Mark, that you had shared earlier, there is a section there about indexing policy transformations. Oops. A lot of details about how it works and like details about like how we use your leftover RUs to do the transformation in the background without impacting your production workload. And then also some sections about how to track progress both in the portal and programmatically, like you mentioned.
Oh, cool.
So that wraps up first part of indexing. We're going to do a shift now to queries. First thing we'll talk about between point reads and queries.
I was just going to ask you that actually. Like, when would I do one versus the other?
Oh, yeah, that's a really, really great question. So answer to that is a query will always work, right? If you aren't sure whether you want to use a point read or a query, like you mentioned, a query is going to work in any situation. However, a point read is better if you just want to read one specific document and you know both its ID and partition key value. So this is how I do a point read. By reading the ID order 1-3, the partition key was Tim 1-2-3-4. This is how I would do a point read to read that specific document. Basically a key value lookup if you know the ID and partition key. And here's a query, right? It's an equivalent query where I have my ID and I have the customer ID, and we get the same result, right? We get the same answer, we get one document. However, there are some differences to keep in mind here. In general, the latency for point reads is going to be slightly better than queries. Point reads are almost always less than 10 milliseconds. In fact, if you look at the median point read latency in Cosmos DB, it's about 2 or 3 milliseconds, and sometimes even less than that. So insanely low latency, like actually pretty similar to what you get like a cache, right, for a key value lookup. Simple queries can be that fast, but in general, they are going to be a little higher. Even the simplest of queries are going to be like 10 to 20 milliseconds. So if latency is important and you want the lowest possible latency in Cosmos DB, Often customers will think of caching. You actually want to think of point reads. If you have key value lookups, model your data so that you can access your data with point reads instead of queries. Point reads also.
That makes sense. So if I'm just looking up a single row of data, I know my partition key and I know my ID, just always use the point read, the read item async.
That's spot on. Yeah, that's what you want to use. It's also going to cost 1 RU if it's a small document. If it's a bigger document, it might cost a little more, but it's always going to be less than a query. So if you have a query and it's like kind of fits this pattern where you're returning one document and you're putting on the ID and partition key, like a light bulb should go off in your head as, oh, like I could write this query as a point read to easily save on my costs and improve latency.
So I got a question then. If everything is a point read for me, do I need indexing in my collection?
So the great thing about point reads is you actually bypass the index in the query engine. So if all you did was point reads, you don't necessarily need indexes.
So if I had a key value store, I could basically just turn indexing off, is what you're saying.
Yeah, you'd be totally okay doing that. I mean, Cosmos DB is a super cost-effective and highly scalable, highly performant key value store. We have a lot of customers that actually have read-heavy workloads that are exclusively point reads. So if you imagine, like, you do 5,000 reads per second of point reads. I mean, how many RUs would you need if each one cost 1 RU?
5,000?
And if you think about that, that's actually like a gigantic scale, right? 5,000 reads per second, that's huge.
Yeah.
Figure out the cost of that, actually doesn't come out to very much money at all. So, I mean, point read workloads on Cosmos DB, key value workloads are extremely cost effective.
Hey, I got some more questions here from our viewers. So from Ben here, to clarify, point reads can only be done via SDK, correct?
That's exactly right. You can't do them in the portal. And this, honestly, as a product manager on Cosmos DB, is something I really want us to add in the future, because it might not be obvious to you as a customer that you can't do point reads, or that point reads even exist, right? So through the portal, you can only do queries. Through the SDK, you can do both queries and point reads. So if you want,
I had another question here. Same thing. Like the only way, do this in the portal. So it's a great question. You know what? I get that on our backlog for next semester. So
yeah, you actually have to fire up the SDK, do this type of request, and like look at the request charge. But I agree. It's like not immediately obvious, and it would be a great thing for us to add in the portal, just to get visibility. I
got another question for you. Is there any documentation about how data is physically stored in an index?
There's a really great white paper on it. It's a few years old, but honestly, it's still pretty up to date. I don't have the link handy, but Mark, if you have like a browser open, it's if you just look up Dharma Shukla Cosmos DB indexing, it'll be like the first thing that comes up, and it's a really great resource. And if anybody's watching, you can also find it pretty quickly that way.
Yeah, let's see if I can find this. This is the schema agnostic indexing. This is the vldb.org paper, I believe.
Yeah, that's right.
Yeah, let me see if I can stick that in here. Yeah, so really easy URL there, but I'll leave it up for a little bit so you can copy it and check it out. But yeah, okay, cool.
So getting back to point reads and queries, like the theme to emphasize is wherever possible, do point reads, because they're just more cost effective, latency is more predictable, and it's just easy, right? Easy just to send a simple key value lookup rather than a query. Now, that's not to say you shouldn't do queries. Like, there's plenty of workloads out there. In fact, the majority of workloads need to do queries. So you should think of Cosmos DB as a really awesome key value store that also just happens to have a query engine that you can use for more complex reads. And if you need to do more complex queries, like, I mean, that's why we support a SQL query language in Cosmos DB, and by all means, you should use it. But it's good to reserve those cases where you absolutely must use queries. So if you need to return more than one document at once, I mean, that's what queries are made for. And if you need to do things like aggregates, order by, like, these are great use cases for doing queries. And of course, with point reads, you must include the partition key. In queries, you should include the partition key. In most cases, it's strongly recommended, but it is not absolutely required. The next thing that we'll kind of transition to is cross-partition queries in Cosmos DB.
Oh yeah, that's a great topic.
So Mark, I have a question for you. What's the first thing that you think about when I mention cross-partition queries?
Failure at modeling and partitioning my data, or failure at partition strategies, I guess.
Yeah.
Immediately comes to mind is if I'm running cross-partition queries, particularly in a high concurrency cross-partition queries, then I made a mistake modeling and partitioning my data.
That's right. If you're using cross-partition queries with high concurrency, that's actually a really important word that you use there. You've made a mistake. Like, that is not a best practice. I'll twist your wording a little bit, right? Let's say instead of saying high concurrency, you said maybe it's a query that you only run every once in a while. In cases like this, obviously cross-partition queries aren't ideal, but they're okay. Like, they're not this terrible, terrible thing that like you should avoid at all costs. You want to think of cross-partition queries as the thing you want to avoid if it's your most frequent query. So if you were a really, really large-scale Cosmos DB customer that had a huge amount of data and a really big app, if you list out the top queries that you run against your data, like, hopefully these queries are not cross-partition. However, if you were a smaller customer, if you were a customer that, let's say, had a lot of unpredictable types of queries run, cross-partition queries, they might be unavoidable and they might not be all that bad. So just to give an example, I'm going to run, and remember this data here that we had talked about earlier, it's partitioned on job, right? So we have different possible jobs, developer, product manager, things like that. So if I go and run icon, cool. If I go and run a query, I'll just take one. If I run a query where it's top one, where c.job is equal to developer, X that out. Will this be in partition or cross partition?
Yeah, in partition.
In partition, super cheap, right? Great way to verify if a query is in partition is to click on these query metrics down here. When you click that, you get a really, really nice spreadsheet. And of course, you can log this in the SDK, but I mean, it's just a lot quicker to grab the spreadsheet, right? It takes you 30 seconds to go and grab it. When you open this up, you'll see some query metrics for query execution. And here we have one row per partition key range ID, which is another word for physical partition. So if you just see one row of these here, it means query only went to one partition, one physical partition.
Huh. Cool. Now, I never knew that.
It's really useful. It's nice. Yeah. Obviously, it's nice to log these things, but if you just want a quick answer, really, really nice. Now I'll filter a name. My name is Mark Brown. Is this in partition or cross partition?
Cross partition, and I can see the request charge there as well.
Quite a bit higher, more RUs. So download these query metrics. Now, how many possible names do you think I have in this container?
Well, I don't know. How many rows have you got?
I mean, it's thousands, potentially even hundreds of thousands, right, of possible names. So I guess explain to me then, when I pull this up and look at the data, why do I only have 10 rows here? Why don't I have, let's say, hundreds of rows, right, or thousands of rows, because there's thousands of possible names. It looks like.
I'm guessing there's 10 physical partitions behind this container.
Exactly right. So when we say cross-partition query, we're actually a little sloppy with that wording, right? That's a really important thing that you pointed out, Mark, is it's cross-partition, and it's bad because it's cross-physical partition. So in each of your physical partitions, we needed to go and run the query. And each execution of the query on each physical partition was separate and independent from the other. So instead of needing to run the query once, we basically ran it 10 times. Now, I mean, a lot of people, when they use Cosmos DB, partitioning might be a pretty new concept. So it's good to talk about the difference between logical partitions, like the partition key that you specify, and the physical partition, would affect cross-partition queries. So if you come to the metrics section, come to storage, and come to metrics classic, there's a really awesome visualization that I think explains this really well. So come to my container. Here are my top partition keys. So if I were to look at the actual partition keys that I specify, which would be different jobs, these are the ones with the most data, right? So developer is a big one, director, coordinator, specialist, administrator, right? Different possible jobs. Now, this doesn't necessarily correspond to the number of physical partitions that I have. Think of it as a one-to-many relationship. If you come down here, this is a graph of all my physical partitions. So, I mean, how many physical partitions do I have? You kind of saw it in the earlier slide with the number of rows in the spreadsheet. I have 10, right? So there's 10 bars. Within each physical partition, there's different possible partition key values. So this one here, in total, it's got about 0.9 GB of data. But I mean, the partition key values within it are supervisor, engineer, and specialist. So if you run a cross-partition query, you're going to run the query once, obviously, when you run it, right? When I go hit play in the browser and I run my query, I run it once. But behind the scenes, it's actually run 10 different times on each of my physical partitions. Now, it's not run one time for each of my partition key values, right? So that's the difference between logical and physical partition. I run the query once per physical partition, but if I have multiple partition keys within the same physical partition, we run it once for all of these together. So as a developer using Cosmos DB, cross-partition queries are bad if you have a lot of physical partitions. They aren't so bad if you only have, let's say, 1 or 2 physical partitions. In fact, if you had a single physical partition, a cross-partition query is going to have virtually the same performance as an in-partition query. Cross-partition queries really only come into play as an important best practice when we're talking about very big scale. Now, as a rough ballpark to kind of gauge how many partitions, physical partitions you have, each one of these physical partitions can accommodate 10,000 RUs or 50 GB of data. So if you provision, let's say, 2,000 RUs in your collection and have 1 GB of data, you only need 1 physical partition, and you'll always only need 1 physical partition. So it's a good thing to keep in mind, right? Cross-partition queries are really only a concern if we're talking about a lot of data and a lot of partitions. And they're only a big problem if you really run that query a lot. If you only run it every once in a while, I wouldn't really stress about it too much.
Yeah, that's what I tell folks as well. If you have like a query you run like once a week or once a month,
yeah,
like some kind of, I don't know, give me my top customers or something like that, you could do that. I had another question too is, I mean, you showed what was essentially a fan out query because it hit every single logical or physical partition in that query. But what if I had a bounded set of logical partitions I wanted to hit? Could I do something like a between in my where statement on a logical partition key, or you're using an in there, I guess? Yeah.
The between, I'd have to double check. I don't think between will work. It's basically anything that we can take and convert to an equality filter. So if you put an equality filter in your query, that's perfect, right? We can use that to basically look and see. We can hash that value and then see, oh, like what physical partition would that have landed on, and then go and run the query there. Within, like if I were to do developer and then, I don't know, product manager, something like that, with a query like this, I'll actually do top 1. So you can compare the argue charges, and we'll just check one document. Query like this, like you can see, 1 partition, it cost about like 3 or so RUs. So I mean, if you do the math, actually go and download the spreadsheet to confirm it. Looks like this one went to 2 partitions because I specified 2 values in in. In is basically just a bunch of equality filters together, right? I could rewrite this query as c.job is equal to developer, or c.job is equal to product manager. So in is just another way of basically saying that.
All right, so no between statements. You can't do range on this thing. So no between, no greater or lesser than, but you can do in or direct equality. Makes sense.
Yeah, that's right. Yeah, thinking about it more between, I guess you wouldn't know the possible values, right? If I said between 3 and 7, you wouldn't know like all the possible values. You know what I mean? Between there, because you wouldn't have enumerated each one. So yeah, in, perfect, you're in good shape. But anything else, whether it's between, like a greater than, less than, that won't work on its own for kind of scoping the query execution. So if I look at the metrics for this query, just as a good example, you can see just 2 partitions, like we suspected. So cross-partition is not bad. It's cross-partition fan out that you want to avoid, right? Where you don't have any where or equality filter for the partition key. Now, one more example I want to go through. This, and we're going to play a little game. We're going to basically, there's going to be 2 different things about these queries. They can either be in partition or cross partition, and they can either use indexes or not fully use indexes. So remember, just a quick refresher, my indexing policy here includes everything except for company and age. Okay? So if I were to do a query where I filter where c.job is equal to developer, is this in partition?
Yes.
And does it use indexes? Quick refresh my indexing policy. Yes, it does. Right?
Sure. Yeah.
Awesome. Super quick. Now, if I were to do a query that, let's say, where another property was c.address is equal to Cosmos road 123. Is this cross partition?
Yes.
But does it use indexes? Yes, it does.
It does, I think, right? Because you're indexing everything.
Yeah, we have include everything in indexes. So we'd be covered, right? Address would be included. So it's cross partition, but just because it's cross partition doesn't mean it can't use indexes. Now, here I'll add a good example. I'll use a property that's in my excludedPaths company. Where company is equal to Microsoft. Just make sure I spelled that right. Okay, I did. Now, in this case, and I think the query running for a really long time will probably give it away. It's obviously cross-partition, but did it use indexes at all?
I'm going to say no, it's scanning everything.
Scanning through is like many gigabytes of data, right? Many records. So it's good to distinguish these, right? This is both cross-partition and didn't use indexes, and obviously we're hit with this gigantic RU charge because of that. But it's totally possible for a cross-partition query, like if I were to run it on address, right? Like a filter on address, for it to be cross-partition, but still use indexes just fine. And the way to see if a query uses indexes, and I'll actually go do one on developer, because you can see, and I'll remove the top one, make it a little bit of an example. The way to see if a query uses indexes is to compare the retrieve dot count and the output dot count. And
I'm going to use that query here so that I can test retry logic and policies, because it's going to max out the RU consumption on my 400 RU container. So,
but yeah, it's good to keep them separate, right? Indexing, like you said, like it'll use all your RUs. If you have a 400 RU container, you're going to absolutely use everything. So it's good to keep these 2 concepts separate: cross-partition and indexes.
So some questions lined up here. How does a Cosmos DB query utilize multiple indexes, including composite indexes?
Great question. So we have a lot of heuristics for this behind the scenes. And these could totally.
Still there?
I'm here. Can you see me okay?
Yeah, I can see you. Looks like we had a hiccup in our internet connectivity.
All right.
Here.
Is it all good now? I haven't.
You're good.
All right, cool. So we'll use multiple indexes. So we have a lot of heuristics that we'll use for what index we utilize, but it's very possible that we'll utilize both like range indexes and composite, or utilize multiple composite. So our recommendation is create both, because it's very possible that if something's covered by composite but not entirely covered, like having that additional range index on other properties will help. Now, it can be a little tough as a user to figure this out right now on your own. So in the coming months, we're actually planning on introducing an indexing policy advisor in Cosmos DB, both in the portal and through the SDK, that just goes and tells you what indexes to add on based on what the query engine would have actually used for that query.
So that indexing advisor is basically looking at the queries that are actually being run, and then coming up with, hey, you should index this property or create this composite index because we see this query running a bunch of times.
That's exactly right. So basically, it kind of works similarly to the query metrics now that you might already be familiar with. Like for each request that you send, we have query metrics. So we're going to add on indexing metrics to this. The indexing metrics will basically be for that particular query, what indexes did we use? And then what indexes would the query have benefited from? So we know what indexes the query engine would have tried to use. And if it would have tried to use them based on its internal heuristics, we would say like, oh, try adding on these indexes because it's likely that these would improve performance and we'd use them. So this is something that we're working on now. It's not quite done yet, but in the coming months, it's something that we want to make available both through the SDK, just like query metrics, and then eventually through the portal, like the query metrics are exposed in the portal now.
Oh, another question. Can I see which index is being used by the query?
Not right now, unfortunately. And I would agree that this is definitely something that's super useful for customers. So that's why it's high on our list to add in the coming months.
It makes sense if you're trying to kind of tune performance, because obviously you're trying to balance the cost of writes and the indexing of that data versus the cost of reads, and knowing like, hey, did that index did that thing do any good? And am I using it? That makes sense. I mean, you could add to indexing advisor maybe or something. So just a comment, it'd be useful or cool to see the number of partitions in the query stats. I think say in the web page or in the web UI rather than downloading it. So
yeah, great point. Web UI, you have to download it, but in the SDK, it's actually you'll literally just see query metrics per partition. So if you had multiple partitions, you just see them twice.
Yeah.
That's if you're logging it, that's how you would see that. But yeah, really great point.
Cool, man. I had some there. So if people want to see some more cross-partition query examples, I've got a link for you there. I'll leave that up for you.
Cool. That's all I have for you today. Thanks again for watching. And this doc in particular that's shared now is really awesome if you wanted to read about that earlier example that I showed with the difference between cross-partition queries and indexing and some useful examples around how partitioning works in Cosmos DB. But I mean, Mark, can't thank you enough. It's great to be on Cosmos DB this week, and I hope all the viewers have really enjoyed it and found this content super useful as they're getting started, or maybe learning more and expanding their expertise on Cosmos DB. Yeah,
thanks, Tim. I learned a bunch of stuff today, actually. I always do, whether it's just listening to you talk about indexing and querying, or whether I'm pestering you on Teams again, trying to help me with a query that I can't get working. So yeah, thanks again. So we'll look forward to having you back, I think in a few weeks, talk about change feed.
That sounds good.
Yeah, that'd be great. So, all right. Well, hey, everybody, thank you very much for tuning in. And we'll see you next week on Azure Cosmos DB Live TV. Thank you.